Hi everyone. So I just want to quickly recap over what we have learned so far. We have learnt quite a few things. We have learned what acute angles mean, obtuse angles, reflex angles, and if you haven't learned some of these things, then just pause the video. Okay, we've learnt right angles, we've learnt straight angles, angles of revolution or revolution. We've learnt what adjacent angles mean, two angles next to each other, words like vertex and arm. And we've learnt complementary angles, we've learnt supplementary angles. Now, I do want to quickly mention that because this video will be moving into slightly more complex problems involving angles and also how to set them out properly, this is how you work it out. So if you have a simple problem like this and it says find x, or what is x in this diagram, what you do is you can write out an equation, x plus 60 equals 180, and then you write the reason for that equation in brackets. Okay, so then you can start solving the equation, and in this case you minus 60 from both sides and you end up with x equals 180 minus 60 and x equals 120. So that's the formal way of doing it, if you want to get full marks for a question like this. Okay, now we're going to move into some less obvious territory, but there's a couple of things that we have already learned that I want to explain in another way as well, just to, not that the first time you learned them wasn't good enough, but my point is that there's different ways of coming to the same conclusions with angles. And you can come at them visually. So, okay, if I have x and z here, I can just look at them and say, look, they must be the same. And that's true. But we can also prove it mathematically. So let's do that. If this is z, then I want to prove that x equals z. And this is how I'm going to do it. I say, first of all, I say x plus y equals 180. Supplementary. I'll have the... Or I don't have to say supplementary afterwards if I've already said it over here. And I can also say z plus y equals 180 because they're supplementary along this line. Oops. Wow. I don't know what's happening over here. Looks like I'm just crossing my T's very strangely with the... It's a glitch or something. Okay. Maybe I'll try not to write too much. So from this, you can say that because x plus y is 180 and z plus y also equals 180 and y isn't changing, then that means x has to equal z. And so we've just proved that x is equal to z. And so that means every time you've got this situation where you've got x which is opposite of z, or two angles that are opposite each other, technically called vertically opposite, they're equal to each other. So that's just one way that you can prove something mathematically. So we're moving towards these mathematical proofs. And that's the same thing. All right. We don't need that. All right. So now we're moving on to something that's new for you, which is transversal. A transversal is a line that crosses over two or more other lines. I'm going to do my best to do this without writing. Which line is the transversal below? Hopefully you can see that this line down here is the transversal because it's crossing over the other two lines. And often we're going to be talking about transversals over parallel lines. These two lines are parallel. How do you know if they're parallel, by the way? You know, because they have little arrows on them. And I didn't label this as parallel, so you couldn't technically know. But now if they have little arrows like this, or maybe double arrows, either way, that means they're parallel. All right, corresponding just means matching. So these two angles are matching. Now, if you've got a transversal across two parallel lines, what happens is these angles are exactly the same if they're in the matching spot here and here. So you can see there's actually more matching angles. So I could write an X here, and then I could also write the X here because these two angles are the same. Or we could have B and B, or there's one more, E and E. So the E's are matching, the B's are matching, the X's are matching. All right. Alternate angles. Now this is happening when you've got a kind of a Z shape like this. This is a backwards Z, but it doesn't matter. Instead of having the, so previously we did corresponding angles, but X is also equal to Y in this situation. Now, if we're going to prove that X is Y, I wonder if you could do that. So if you would like to try and prove this, just pause the video and give it a shot, but otherwise we're going to keep going. Okay, so to prove that X equals Y, what we can do is write another angle here called A. Now you can do this multiple ways. You might have done it a little bit differently, but I can say that A equals X. A equals X, and that's vertically opposite. I'm just writing a short version of this. And then I can also say that A equals Y because we've just talked about how they are corresponding or matching. Okay, and finally, if that's the case, if X equals A and Y equals A, they both equal A, then that means they must be equal to each other as well. So that means, so we can say therefore at the end, X equals Y. Oops, can I just draw a little arrow here, please? Thank you. Okay, just talking to my computer. Everybody does that, right? Okay, so the next one is co-interior angles. We've got another proof challenge. If you would like, pause the video and try and prove this one. But really quick, firstly, if I write a little A here, then we know that X equals A because that's alternate. That's what we just did. And we also know that A plus Y equals 180 because that's supplementary. And what we can do actually is label these as two equations, and we can substitute one into the other by writing, because if we replace A with X, and we're allowed to do that because they're the same thing, then we'll have this. So what we'll do is we're substituting equation 1 into equation 2. So we write 1 into 2, and then we have a weird glitch on the side because why not? 1 into 2. So instead of writing A here, we write X. We're substituting equation 1 into 2. X plus Y equals 180. And that's the proof. Okay. So far, you should know all of these words. If you don't, have a look and see if you can work it out from this video, from another, or from Google or somewhere else. Okay. By the way, this slideshow did say at the start, in 17 slides, you will be able to solve this problem. Okay. You may be able to solve this problem now. I'm not going to do it. I'm going to leave it up to you. If you can solve this, I'll be very impressed. Find all the variables. Okay. I'll leave you with that.